I'm your host, Sean MacKenzie. Thank you for joining once again on my channel on data engineering. In this episode, we go back to our artificial intelligence playlist and our investigation into BERT, and we're going to take a look at how to do our natural language processing model using Python. Now, in our previous video, we did the download and setup of our data set, and that included a training data set and a testing and validation data set. And what that's going to help us do is to give us data for our model. So by training our model on the training data set, we'll be able to do a sentiment analysis of whether or not the movie reviews are positive or negative reviews. Let's get to it. Interested in more cool topics like these? Make sure to check out my Patreon. The link is in the description. Okay guys, so we're going to lay down some groundwork first. BERT is a deep learning model. We're going to use BERT to make a classifier, and an Epoch is a complete pass of our training data set. Generally we have many Epoch, and it gets better over time, and you'll see graphs like these. Now these graphs are from a traditional deep learning model that is not related to language, but you get the idea that generally it gets better over time. Your model loss generally gets lower with time, and you'll have a better confusion matrix for your predictions. And so today's goal, we just want to get to one Epoch, so no graph because it would be a single point. But we want to be able to get there. We're going to check the accuracy. We're going to create a simple user input, and we're going to talk about how we split our data. And today, as you know, we already have the training and test data split, but we're also going to do 20% for validation, so we'll talk about that. We're going to use Atom as our optimizer. We're going to use a custom learning rate, which is quite small, and we're going to talk about a whole bunch of other stuff as we blast through our coding. This is going to go very quickly, so hang on to your seats. Here we go. Okay guys, so in our last video, if you haven't watched that yet, make sure you go back and watch it. We did all the coding for our data set. We did the download, and then we took a look at what the data looks like, and now we're continuing on. Okay, so we are going to be using the auto tune, which kind of does a bunch of magic stuff to do with, auto leveling CPU usage and things like that. And you don't have to use auto tune, but it will make things run a lot more smoothly because it sort of samples some data and then it optimizes everything for the data pipeline that you're trying to do here. So first of all, we're going to set our batch size to 32. I believe that's the default anyway. The seed equal to 42, and then we'll set up our raw training data set here, and that's from the directory that we set up in the previous episode. So we're grabbing that, and you'll notice that we put in the validation split 0.2 in there, and that's going to grab some data for validation so that we can see how the training is progressing as it trains. So you don't have to wait until it's all done and then run your test data through to see how good you were. It does do some awesome stuff along the way, and we're going to grab a validation data set, test data set. Of course, we're also grabbing those ones, and so here is our test data set. That's going to be again the directory that we set up with the data in it that we downloaded from Stanford that has the movie reviews in it, and that's going to be the test folder that you can see there. And we're going to use the same batch size, and we'll do some optimization for the inputs there using the buffer size equal to auto tune. So that's going to get us our test data set, and that is good to go there. Now we missed a thing there. We do need to put our training data set in there, as that is our actual training data set that we'll use in the model. You can see we got the raw training data set above, so make sure you put this statement just below there. That's going to be your training data set, and we'll do the same for the validation data set. We need to make sure we have that in advance, so we'll grab that as well. So that's going to be from directory, and that's going to be the 20% of the data that's used and that's going to go toward validation as well. So we can set the validation split equal to 0.2, and then the subset is going to be validation, and away we go. Okay, let's take a good look there. We've got our validation data set. That is good to go, and that's what we want to see there. So we can continue on after our test data set has been set up there, and we are good to go. Now we're going to have two big lists for model selection, because we can actually use several models, and I'm going to put this paste in here. I'll put it in the description so that you guys can use it right away. And this is where you can see all those different model names. One is Electra. There's BERT models from different sizes and things, and you can get small BERT or tiny BERT or normal BERT, and you can use these different ones like Electra, and that's really great. And then there's going to be a map model to process list as well, which I will also put in the description. And those mappings are pretty important, but you can change them up and try them out on your own. Be advised that some of these pre-trained models are quite large, and so you might need a lot of processing power to use them. We're going to be using small BERT and tiny BERT in our demonstration, which are sort of smaller implementations of BERT, and this is the one here. This is tiny BERT here, this L2, and you can look these up and you can see where they fit in the sort of BERT sizes. And so tiny BERT is actually for resource constrained environments, you could say. And so small BERT, it is a small BERT implementation. It has a nickname tiny BERT, and basically it's for if you don't have a ton of processing power. In my case, I've got sort of a very low-level video card that's sort of like the basic one for doing machine learning. But you could actually run tiny BERT without having an NVIDIA video card with the right power to do the bigger models. And so, some BERT deep learning is within your grasp if you want to be able to do that. And so we're going to set up our encoder. We've chosen a BERT model name there, so we're going to set up that encoder and the pre-processing model, which is going to do the tokenization and everything that's needed for this deep learning model. And so there's our pre-process model. That's what we wanted to see. And then our BERT model, of course, that's what we're going to need. And of course, that is the small BERT model called tiny BERT. And we are good to go. So what we need to do now is we need to create our classifier model from the BERT model that we've chosen. And we'll do a function for that. We'll do a function called makeClassifier, and we're going to specify our inputs here, and that will also include the type as a string and our shape, and then we'll do the pre-processing layer. That's going to be our Keras layer, and from that we'll be using the tfhub underscore handle preprocess that we specified up above there, and it's going to be called pre-processing. From there we'll do the encoder inputs, and that will be our pre-processing layer with the text input as the argument there, and we can set our encoder equal to the Keras layer encoder that we chose up above there, and we'll set that as trainable equal to true. The name is BERT encoder, and then we'll set our outputs, and our outputs will of course be the encoder using the pre-processing layer that we specified there, and then we can look at some of the outputs. So the net will be the outputs pooled output, and we can slowly build on that from there for our net there. So we'll go ahead and add the dropout at 0.1. Dropout can help a lot with your model. especially with language models. Dropout seems to work fairly well. And then we'll have one layer which is dense with an output of one dimension, and no activation means that it will be a linear activation. We've got everything that we want there. And that is going to return a TensorFlow Keras model that we can use for our little project here. So that's a nice little function that we can use. We can actually reuse it if we want to create different things. Okay, so let's go ahead and make our model there. So we set our classifier model equal to make classifier. That is our function that we just created. And we're also going to need to specify our loss, and that's going to be a binary cross entropy because we are doing a true or false in our output. So our classification is a 1 or a 0. And we're going to set up our metrics as a binary accuracy metrics from TensorFlow metrics there. So that's going to give us some stuff that we can look at. And then we're going to set our epoch and learning rate. And like I said at the beginning of the video, we're doing one epoch. We just want to do one today to say that we got there. And then we're going to expand that in the next episode. Our learning rate is going to be 0.00003, and that is going to be a much lower learning rate or smaller learning rate than is the default, and that's going to set us up for sort of more gradual learning. And then we'll set our optimizer equal to Atom, which is what we imported at the top of this script, and then we'll go ahead and do our compile. And so that'll be classifier model.compile. We're going to set our optimizer equal to our optimizer, loss equal to our loss that we put in there, and our metrics equal to metrics to specify the metrics we want. And then we'll do history equals classifier model.fit. So we're going to capture the history of training into a variable there, the history variable, and we're going to set x equal to our training data set. We're going to set the validation data equal to our validation data set, the number of epochs equal to what we specified for epochs in our variable up above there. And the fit is what's going to take the time. You'll see lots of that happening in the console as it runs, as it does training, and then we can basically test our result against our test database, and we can get our loss and accuracy variables loaded from there. And so you can see we've got our classifier.model.evaluate there, and that's going to evaluate the test data to see how accurate our model actually was. So from there, it's really, we've got it completed at that point. We have a model, we've trained it, and what we want to do now is sort of get some history. So we want to grab that history variable that we loaded so that we can have some idea of what's going on. And so I'm going to do this section here mostly for the follow-up episode, because we're going to have more than one epoch. So you might remember I was saying in the very beginning of this video that we actually are only going to have one epoch in this particular run through, and so that's only going to be a single point on a graph. It's not going to be a very good graph, but I'm going to put this in here. This is pretty standard stuff for sort of grabbing and plotting our data that we've received back from our training exercise and our testing exercise. And so we can grab that data and we can plot it, and we'll use that in a matplotlib figure, and we'll go ahead and plot that, and that'll sort of spit it out as the script runs, and so we can look at it and then close it, and then it'll open the next one that we want to look at. If you're using Jupyter Notebook, of course, it'll work differently. You can put those in. You can actually look at those directly and not worry about this part of it, but we're doing this right from the command line. So here we go. We're going to plot some stuff. We'll put the training loss on one axis and the validation loss on another, and then we can sort of plot put our labels on there, and we'll do a legend and then we'll show it. And the show command is where it's going to pop up as the script is running. It'll stop the script while it pops up. So that'll be kind of interesting for you guys to see. And then once it's shown itself and we close it, then we're going to change that plot, and we're going to plot the training accuracy instead of the loss. And so that'll help us to take a look at that. So there we go. We can put our training accuracy in there from the ACC variable, and then the validation accuracy, we'll put that in there. So those should be pretty close to each other, those two. But we'll see. Obviously, like I said, on this round we're not going to see anything, but we will in the next video. We're going to see that pop up. We're just going to blast through this and make sure this is all in our script for today. So there we go. We'll end with plot show there, and that's going to give us a graph once we do more than one epoch. And so we'll go ahead and set some other stuff, and now we're going to do a little loop. We're going to do a custom input. That's going to be something that we can type into the to test against the model, and we'll just do a loop here. While custom input does not equal exit, we're going to do a loop, and we'll say, hey, enter your movie review, and custom input will be the input you put in, and then we'll just say our user entry is equal to the custom input, and the counter, we'll put a counter on each of these, and so that we know how many we put in, and then we'll just output the result once we've actually checked it here. So in order to test our custom input that we typed into the console, we'll say results equals tensorflow.sigmoid. That's our function there. We're going to put our classifier model into that, which returns a value between 0 and 1. We're passing in our model with our user entry as a argument there, and then we can grab the results from that. Now the result we're looking for is in the sort of first position, the 0, 0 position, and we can take a look and see what we got there. So we can say if the result is greater than or equal to 5.5, then we're going to say that's a positive review, and then we can say else if it is not greater than 5, then we'll say the review is negative, and of course that's all other cases because we are receiving back a number between 0 and 1. And so that's going to give us our script that we need. Once we're done there, we can print done after we've exited our user input. So we should have everything we need there. There's our classifier, our inputs, our pre-processing, our encoder. Oh, make sure you put that equals right after the shape in between the brackets there. I missed that, so that was a good look through. There's our net and our model return, and that looks pretty good. So let's go ahead and run this and see what happens here. Now, note I did try to run this before. That's all the garbage at the top of the screen here, and I got an error when I ran it. Now, if you watch this in Task Manager, make sure you change that copy to CUDA for that one view so that you can see the progress of your CUDA installation, which will definitely be calculating much faster than natively using the CPU. And so there we go. We're off to the races. It has detected my lowly GTX 1050 Ti, and it has already made it to compile and fit, and there we go. It is doing the first epoch, which is exactly what we want to see there, and it is using tiny BERT, so it is calculating actually much faster than when I tried the full BERT installation on another day. And so you can see it's blasting through, and it's using that CUDA core. Take a look at that up in your task manager. You want to make sure that your CUDA is being utilized because it will save a ton of time over your CPU running it. So there we go. There it is again. That's our CUDA core there, and you can see it's 41% and it's using about 31% of the GPU, and it is done. And we got 66 on the binary accuracy there, with the validation at 72. So it actually validated a little bit better, so 73%, and it's just wrapping up the model there to get the final accuracy. And it looks like our accuracy is about 72% with just one epoch, which is pretty amazing. Now BERT, typically what I've seen is it doesn't actually train over many epoch like other deep learning models. Typically it's a few models, and it's so powerful on its own that that's usually enough, and you might actually get falling accuracy after that. But for one epoch on TinyBERT, this is actually very good. And if we can get this with one epoch with TinyBERT, imagine what we can do with bigger, more powerful models like small BERT, or the full-size BERT. So there we go. We picked up our keys and everything, and it says that it's plotting now. Now remember, I said that one's going to be empty and that one's going to be empty. Those are our two plots because we only have one epoch. But we can test this out on our own. We can check it out. We can type in our own review now. Please enter your review. That movie was great, and that got a positive review. What a terrible movie that was. Reviews negative. That movie was kind of good, if I could type here, but I don't think people will like it. Something middling there. That seems to be kind of a positive review according to TinyBERT. And this movie is the best I've ever seen, hands down. That's a positive review. You can enter perfect or whatever, and it will seem to pick it up. Type in exit, and you're out. In our next episode in this series, we're going to expand that to 5 epoch to see what kind of results we get. And then we're going to upgrade our model to small BERT to see how powerful we can actually make it. Also, we'll talk about tweaking our model, like using different optimizers from Atom and other factors. Are you a programming hotshot looking for your next gig? Make sure to check out the additional links in the description.